So, what is Passive House? This independent research institute is one of the fastest growing sustainability certifications in the construction world. But what makes it different? And more importantly, why should you care? So stick around because by the end of this, you might just become a Passive House fan. Alright, let's rewind a bit. Passive House actually started as a conversation. Yep, it's two smart dudes talking. On one side, we got Bo Adamsson, a Swedish professor and a structural engineer. On the other, Wolfgang Feist, a German physicist. They had a simple but game-changing idea. What if we could design buildings so energy efficient they barely needed heating or cooling? Now fast forward through a bunch of research projects with funding from the German state of Hessen. In 1991, boom! The first Passive House resident was built in Darmstadt, Germany. 5 years later, the Passive House Institute was officially founded. But Passive House wasn't built from scratch, it actually had a precursor, the micro-low passive houses of the 1970s. Why the 70s? Well, the energy crisis. In 1973, the OPEC oil embargo hit the US and Canada hard.
The Middle East war produced developments all over the world today. The oil-producing countries of the Arab world decided to use their oil as a political weapon. They will reduce oil production by 5% a month until the Israelis withdraw from occupied territories.
Suddenly, energy efficiency wasn't just a good idea, it was a survival tactic. One of the most famous buildings from this time? The Saskatchewan Conservation House in Regina. This thing was ahead of its time. The team behind it developed the first ever blower door test and their own heat recovery air exchanger. This house could handle temperatures from minus 40 degrees Celsius to positive 40 degrees Celsius. So, what actually makes a passive house passive house? Well, it all comes down to 5 core principles. Number 1, super insulation. It keeps heat in during winter and out during summer. 2, an airtight construction. No sneaky drafts wasting your energy. Number 3, thermal bridge design. No weak spots where heat can escape. Number 4, high quality windows with optimized solar orientation. So you have to make sure the sun does half the work for you. And number 5, ventilation system with heat recovery. You have fresh air without energy loss. Now it sounds simple, right? But trust me, getting it right is where the real challenge is. Now you might be wondering, how does Passive House compare to other types of certifications, like for example LEED? Well, the easiest way to think about it is that LEED is a prescriptive based certification, meaning it tells you how to achieve sustainability, specific methods, materials. You have a specific checklist. Passive House, on the other hand, is a performance-based certification. It gives you a goal, which is a crazy low energy demand, and then tells you, well, you figured out how to do it. It's like following a recipe versus being given a target and cooking however you want it. Alright, let's talk numbers, because theory is great, but real-world impact is what really matters. Let's take South Ontario as an example. So according to the Ontario Building Code, standard walls need an R value of between 22 and 28 and attics between an R value of 50. It depends more or less what part of South Ontario you are. The City of Toronto Green Standards says a typical multi-unit residential building uses about 130 to 135 kilowatt hour per square meter per year for heating. And a passive house building? Well, just 15 kilowatt hour per square meter per year. That's 9 times less energy use. And less energy means lower carbon emission and lower energy bills. It's your wallet that will thank you. But Passive House isn't just about efficiency, it's also about comfort and health. Have you ever been in a house that's technically warm but still feels cold? That's because temperature isn't everything. Things like surface temperature and humidity also matter. ASHRAE recommends an indoor humidity between 35% and 65%. But here is one disclaimer. What's comfortable for one person might be uncomfortable for another. Take me, or people from where I come from, Lima, Peru. 100% humidity is just our normal weather. So in my first winter here, like dry skin, sore throat, I was basically feeling like a fish out of the water, and the humidity percentage was around 75 or 80, which is high for ASHRAE standards, but for me it was too dry. Passive House keeps humidity stable and eliminate cold drafts, so you don't have to deal with these extremes either. Apart from that, it also helps you with better air quality. Passive House building use high efficiency ventilation system, meaning you're breathing fresher air all the time. That's why more schools are adopting Passive House standards, to keep kids and teachers healthier. Now, it's probably gonna be easier to understand the impact if we see a real world example, like Hotel Marcel in New Haven. This was a retrofit project that turned an old inefficient building into a Passive House certified hotel. The exterior walls have a U value of 0.022 and the roof a U value of 0.019. Now, it sounds simple, but here is where Passive House designers really earn their money. It's all in the airtight detailing and thermal bridging solutions. Get that wrong, and the whole design falls apart. It's not just putting more insulation into the walls. So there you have it. Passive House in a nutshell. It slashes your energy use, it keeps you comfortable, and it improves indoor air quality. And honestly, with buildings responsible for nearly 40% of global emissions, we need a smarter solution, and Passive House can definitely be one of them. Now, if you want to see more case study, check out the link in the description. Otherwise, that's it for this quick intro to Passive House. Thanks for watching, and I'll see you in the next one.